Today, one special problem regarding second order derivative is solved. Now, given that y to the power 1 by m plus y to the power minus 1 by m is equal to 2x, we have to prove that x square minus 1 y2 plus x y1 equal to m square into y. There are so many examples are given in the question paper. In case of the value of m is equal to, that may be 3, maybe 5 and such. But this is a common problem where m is unknown. Now differentiate with respect to x. Differentiate with respect to x on both sides. Okay. Now y to the power 1 m into y to the power 1 by m minus 1 into dy dx, derivative of y with respect to x. First term, second term, minus 1 by m y to the power minus 1 dy dx. Everyone knows it. That is equal to 2. Differential coefficient of x with respect to x will be 1. Next line, if we multiplying both sides by m, y to the power my, 1 by m into y, m into y minus y to the power minus 1 by m, that is y1, dy dx means y1 is equal to 2. Now dy dx stands for y1. Now y to the power 1 by m minus y to the power minus 1 by m into y1 is equal to 2my. Now squaring on both sides, very simple. Squaring both sides, y to the power 1 by m minus y to the power minus 1 by m whole square y1 square is equal to 4m square y square. Now a minus b whole square can be written as y to the power 1 by m plus y to the power minus 1 by m whole square minus 4 into y to the power minus 1 by m within the bracket. Next step, y1 square is equal to 4m square y square. Now that is given, that is 4x square minus 4 y to the power 1 by m minus 1 by m within the bracket y1 square is equal to 4 m square y square. Next line, if we divided both sides by 4, we get x square minus 1 y to the power m will be cancelled, y to the 0, there is the 1, y1 square is equal to m square y square. 4 is cancelled from both sides. Finally, again we differentiate with respect to x on both sides. Now x square minus 1 into 2y1 and differential coefficient of y1 with respect to x, we get y2, where y2 stands for d2y by dx2. Okay, second y1 square into first term derivative 2x, first unchanged, second derivative, second unchanged, first derivative, that is equal to m square is constant, m square into 2y y1. Now we get the result if we divided both sides by 2y1. If we divided both sides by 2y1, we get the result x square minus y1 y2 plus x y1 is equal to m square y. That's the final result. Now in case of the value of m is 3, what result rise? X square minus 1 into y2 plus x y1 is equal to m square means 9 into y. In case of 5, that will be, now this is a very simple example to remember. When m is equal to 5, m is equal to 3 is given, n is equal to 7 is given, I can easily sure that the answer is right or not. Okay, therefore this it's proved. Okay, thanks for the next class.